What you need to understand about polar coordinates is that they are just a different system of giving coordinates. So you are used to these Cartesian coordinates, which are x comma y. So that's the system you're used to. You've seen that system before. You've used it a lot. So a new system that you're going to be talking about today is polar coordinates. And polar coordinates are listed as r comma theta, right, where r is the radius and theta is the angle. Both of those based from the origin. The radius is from the origin, and the angle is from is your usual angle measures, so degrees or radians based on 0 is out to the right on the coordinate plane. And so this is kind of used to this already in a way. So there's some properties about these, basically to make them interchangeable. For instance, r squared, so the radius of our polar coordinate system, is going to be equal to x squared plus y squared. Now that may look really familiar to you, and it should. R squared equals x squared plus y squared is very similar to a squared, or sorry, yeah, essentially a squared plus b squared equals c squared. So let me give you a visual on that. And let's start with this. So I have a coordinate plane, and I'm going to make a point out here. And I can actually label this point with two different systems. I can label it with polar coordinates. So we'll label that with P, the polar coordinates. And then the Cartesian coordinates is another way I could label this. Now the polar coordinates for this point, let's say the polar coordinates are 2 comma pi over 4. Right, what that means is my radius is 2, so my distance from the origin out to my point is 2, and then the angle is pi over 4, which we know to be the same thing as 45 degrees. So if I had a point that was 2 units away from the origin, and that segment that connects the origin and that point is 45 degrees from my x-axis, my positive x-axis, then the coordinates are 2 comma pi over 4. Now if I were to find the Cartesian coordinates for this same thing, I would basically want to know how far out along the x-axis is this and how far up from the x-axis is this. That's how we do Cartesian coordinates. Now I already know from personal experience that this is going to be the square root of 2 for both of those sides. So my Cartesian coordinates would be square root of 2 comma square root of 2. And so again, these two systems are interchangeable. One is based on a radius length and a point, or sorry, and an angle to get to the point. And the other one's based on how far to the right or to the left, and then how far up or down is the point from the origin. So going back to this, r squared equals x squared plus y squared. Well, my radius is the hypotenuse of this right triangle. That's why if I take the x and the y coordinates, square them, and add them, it'll equal the square of my hypotenuse. All right, what other things are there? Well, if I want to know what theta is, and I don't know to start, then I need to use inverse tangent. And we'll do inverse tangent of y over x. Remember, tangent itself is the ratio between y over x. So to find my angle, then I would inverse that particular thing. Now, here's the key. This is plus pi, which is the same thing as saying plus 180 degrees sometimes. Now, sometimes, what the heck is that all about? You're not going to tell me when? Well, I'm going to tell you when, but you're going to have to remember this. All right? It is plus pi sometimes because inverse tangent only gives you coordinates, or sorry, only gives you an angle in the fourth and the first quadrant when you do it in your calculator. And so if it only will give you these, but you know your point is over in one of the other two quadrants, then that's where you have to do a little bit of thinking. That's why we have the plus pi sometimes. So for instance, if I look at my point, that's radical 2 comma radical 2, if I actually just go to the other end, if I go out here into the third quadrant, a distance of 2, and so therefore it's negative radical 2 and negative radical 2. When I do tangent of that, tangent of my angle is going to be negative radical 2, sorry, this one, negative radical 2 over negative radical 2. That's also 1, just as if I did tangent of radical 2 over radical 2. That's also 1. Since those two are the same thing, if when I do inverse tangent, my calculator can only give me one value. So it gives me the first quadrant value. So I need to add pi to my quadrant value, or to this angle value, in order to get it to be a third quadrant angle value. So it involves some thinking. All right, and we'll continue to practice this over time, but that's kind of the basic idea. Also, if we get an angle down here, then I have to add pi to get the angle that I want if I'm trying to get a second quadrant angle. The fourth quadrant angle, technically you could list it as the negative angle, or you could list it as the positive angle. You just have to remember to add 2 pi to get the positive angle when you're given a negative angle. All right, so that's that. It's kind of a reminder of some stuff that we've already learned, plus adding in the polar coordinate aspect of it. All right, now let's say if we were trying to figure out Cartesian coordinates and we knew the polar coordinates. Well, this one should look really familiar. X is r cosine theta. We've actually already talked about that before. And y is r sine theta. And so if I'm trying to get my Cartesian coordinates and I know the polar coordinates, I literally just put r cosine of theta in to get my x and r sine theta to get my y. So it's actually a slightly easier conversion going from polar to Cartesian than vice versa.